whether your X variable has a relationship with your Y variable or not. Particularly, if your X variable has a linear relationship with your Y, the correlation study will help you to understand that, will help you to understand the strength of the linear relationship. When I say linear, it's a straight line relationship, right? So we'll understand what is correlation. We'll understand what is Pearson correlation coefficient. And also we will see an example, and to interpret the correlation report, we'll see some cases. See here, I am showing 3 diagrams here. Diagram 1, diagram 2, diagram 3. So these diagrams are nothing but your scatter diagram, the 7QC tool, one of the 7QC tool. When I say it is a scatter diagram, it will have 2 axes. See here, there is an x-axis, there is a y-axis. You can see it in all the 3. The x-axis will represent your x variable, which is otherwise called predictor variable. Your y-axis is called as response variable. Your x is called predictor variable and y is called your x variable is called predictor and the y variable is called response variable. Is there a linear relationship that exists between your x variable and y variable? You can understand by conducting a correlation analysis. And now look at the first diagram, scatter diagram, and also the second one and also the third one. Now looking at the third one, tell me how the points are distributed here. Is that the points are completely scattered, or do you see a pattern?
Scattered.
Completely scattered. If the points are completely scattered, we call it random distribution. We call it random distribution. If it is randomly distributed, it simply means there is no relationship. It simply means there is no relationship between X and Y. But look at the first diagram. How the points are distributed now. Do you see a random or a scatter pattern here? This is the straight line pattern, a non-random pattern. If you see all the people walking in all the students in a school standing in a straight line, can you understand? The teacher is making the student to stand in a straight line, and that is why the kids are standing in a straight line. Same way, if your points are falling perfectly in a straight line, you can understand your X is controlling your Y. You can understand your X is controlling your Y. And this kind of relationship is called linear relationship. I call it linear because the points are lying in a straight line pattern. And moreover, look at the first diagram. As the X increases, the Y increases upward. Am I right? This is called positive correlation. But on the second diagram, when the X increases, what happens to your Y? Decreases. So this is called a negative correlation. And here the first and 2, I call it strong correlation. Why do I use the word strong? The points are falling in a perfect straight line. When the points are falling in a perfect straight line, I will consider the relationship as strong relationship, right? So now, generally the correlation coefficient, the linearity can be measured using a coefficient called Pearson correlation coefficient. The symbol used is small r. The small r will range between -1 and +1. 0 to +1 indicates positive correlation. 0 to -1 indicates negative correlation. Value closer to 1 means perfect correlation. Value closer to 0 means zero correlation. Accordingly, the relationship is categorized into 3. 0 to 0.4 is called weak correlation. 0.4 to 0.7 is called moderate correlation. 0.7 to 1 is called strong correlation. And this is the formula. This is the formula you can use to calculate the R value. Here N is the number of data you have for X and Y. X bar is the average of X bar. Y bar is the average of Y bar. Sx is the standard deviation of X data. Sy is the standard deviation of Y data. This means summation. When you calculate this, you get the R value. When the R value is found to be 0, what you can understand? There is no relationship. When the R value is found to be closer to 1, you can understand perfect linear relationship, right? And now this is again another scatter diagram. The x-axis. What is written on the x-axis? Calories consumed. Every day we are eating food. That means we are consuming calorie. Calorie consumption is a continuous data or a discrete data? Calorie consumption, is it a continuous data?
Continuous data.
Continuous data. And the Y variable is weight gain. More calories you consume, more weight you will gain. So weight is a continuous data or discrete data?
Continuous.
Continuous.
Always for plotting a scatter diagram, both your X variable and Y variable should be continuous data. Then only you can plot a scatter diagram. And the blue color dots are the scatter diagram or scattered dots. But looking at the blue color dots, can you understand the relationship is, somewhat linear. So I draw a red color line. The red color line is called regression line. An approximate line indicating the pattern of relationship. See, the points are not perfectly straight line, but I assume an approximately straight line. I simply made the straight line pass through majority of the points, and this line definitely has got some error. The error associated in drawing the line is called residual. That residual should be minimum. When residual is minimum, the regression equation will have a lot of strength. And now looking at the diagram, can you tell me, is it a strong relationship or weak relationship? Can you tell me?
Strong relationship.
Yes, very good. This is strong relationship. Why do you say strong? The points are closer to the straight line. Most of the points are closer to the straight line. So you call the relationship strong. If the points are here, I will call it weak relationship. If the points are here, I will call it weak. But the points are close to the straight line, so I call it strong relationship. And also the relationship is positive or negative?
Positive.
Very good. So always when you want to interpret a correlation analysis, you must see the scatter diagram. Without seeing the scatter diagram, you should not directly go to the R value. And the significance of correlation must be confirmed with the P value. In the song also you could have seen, leave out if it is IP, right? So P means probability of significance. It's a very important tool in decision making. If you want to learn the P value, I have posted 3 videos in my YouTube channel, right? Explaining about probability of significance, P value in 3 stages, 10 minutes each. And those of you who would like to learn it, you can watch the video in my channel. But that's a very powerful tool which you will be learning in the green belt. And never conclude the relationship is cause and effect simply based on a correlation. Numbers sometimes can demonstrate correlation, but reality, there may be no relationship. You have to be very careful, right? So statistics or anything you are using, whether engineering or science, whatever, if you learned, yes, use it, but ultimately your common sense is important. Simply since the correlation is close to 1, you cannot say this is the factor, this is the critical factor. No, still criticality may be different. So for always to understand the criticality, in addition to statistics, in addition to your engineering and scientific knowledge, you must use common sense. The correlation coefficient is sensitive to outlier. One of you already asked me, if there are outlier in your data, please eliminate the outlier before calculating any coefficient, whether it is Pearson coefficient or whatever. You must eliminate the outlier. Now this diagram, tell me what is the kind of relationship here? Is the relationship is positive or negative?
Positive.
Strong or weak?
Strong.
Strong.
Okay. And here the second, this diagram?
Negative.
This
Strong
is strong,
negative.
strong, negative. Strong positive, strong negative. And what is this relationship?
Moderate.
Negative.
Positive.
You can see most of the points are away from the
Yes.
line. It is weak, right? So you can say weak. The first one is weak positive. The second one is weak negative.
Negative.
Here,
No correlation.
here,
Correlation is there, sir.
no. In both cases, there is no correlation. In both cases, no correlation. But in the first case, no relationship. But in the last case, there is a parabolic relationship. So what do you understand out of this? The Pearson coefficient checks only the linearity. Here in the last diagram, there is no linearity, but there is a curvilinear relationship, right? So no correlation simply doesn't mean no relation. Even if there is no correlation, there could be some other relationship other than linearity. I don't know how many of you understood. See here in a company manufacturing castings, there is a problem. What is the problem? And porosity. The castings are becoming porous. And experts are telling, or brainstorming, discussion, cause and effect discussions revealed that hydrogen content affects the porosity. So you as a yellow belt, you collected some data. One column is porosity, one column is hydrogen content. Now tell me which is X variable and which is Y variable here.
Content is X.
Which is X?
Content.
Hydrogen content is X variable and the porosity is Y variable. So I am plotting a scatter diagram. When you plot the scatter diagram, what do you understand? Is it a positive correlation or negative correlation? Strong or weak?
Positive weak.
Positive weak.
Positive weak correlation. And see, that is why your R value is coming in the range of 0.4 to 0.7, 0.625. And how can I use the R value? R is called Pearson correlation coefficient. I want you to square the R value. When you square the R value, it becomes R square. R square is called coefficient of determination. When you square the R value 0.625 into 0.625, how much you are getting? 0.39. 0.39 simply tells you that the porosity comes because of inadequate or because of the problem with the hydrogen content. See, the problem in hydrogen content causes the porosity. But to what extent? Only to an extent of 39%. It simply means 39% of the porosity is due to the poor quantity of hydrogen in your castings. All of you understand my statement? Porosity problem, 39% of the porosity problem is caused due to the hydrogen content. So if you correct the hydrogen content, 39% of the porosity problem will be solved. Do you get an idea of sufficiency of the... No, you have to square it to understand, because R can be positive or negative. Do you understand? R is positive or negative. I told you, it can be from -1 to +1. But whether the porosity is affected in any direction, that is called a deviation. So deviation can be positive, deviation can be negative, and that is why we are squaring. When you square, the minus and plus both will become plus, and we will be able to account the deviation, right? So R square will give you 39. By squaring the R will help you to understand what percentage of the problem comes because of the hydrogen content. So what is our understanding? 39%. So by optimizing the hydrogen content, you can solve 39% of the problem. When you solve 39% of the problem, tell me, will your company be happy, or they will expect you to solve the remaining problem also?
Solve remaining problem.
Now tell me, how will you solve the remaining problem?
So validate other cause.
By working on
Other causes.
other causes. Very good. Because here the critical factors are not just one factor. Multiple factors are involved. How do I know multiple factors are involved? My R square is already directly telling me. only 39% of the problem is explained by the hydrogen content. Remaining problem, the remaining percentage comes from other causes. For example, the yellow belt training program. I am also teaching, Dr. Ravi also teaching. Am I right? Yes or no?
Yes, yes.
Yes, sir.
Yeah. So now, for example, 70% of the content I have covered. 30% of the content Dr. Ravi covered. So both put together is 100%. Similarly, 39% of the problem of porosity is contributed by the poor hydrogen content. So correct the hydrogen content, 39% of the problem will get solved. But still 61% of the porosity will remain. So you are getting the idea by looking at the correlation. Same way here, there are two data. One is calorie consumption, another one is weight gain. Now tell me which is Y variable here, weight gain or calorie consumption?
Calorie consumption.
What do you mean by Y variable? What do you mean by X variable? X variable means the factor which is under direct control is called X variable. Now which one you can directly control, weight or calories?
Calories.
Calories.
When I want you to reduce to half of the weight, you can't cut your weight to half immediately. Rather, you can start consuming less calories, isn't it? So the factor which is under your control is calories. So calories is X variable, weight gain is Y variable. Now, what is the relationship you are seeing here in the scatter?
Positive, strong.
Positive, strong. The word strong is again confirmed by the R value. How much is the R value? 0.97. So calculate R square. R square is how much? 0.94.
94.
What does it mean? 94% of the changes in your body weight
Depends on calories.
depends on calories. Please note, this is not true for each one of you. You should not try this tomorrow. Human body can behave differently, isn't it? According to your body condition, you have to collect data from your body to find out the R value. Then you can offer a solution. So this, whatever we are discussing, is applicable to the person from whom the data is collected. All of you understand what is that I'm speaking?
Yes, sir.
Statistics should be used wisely. If you collect data from one Mr. X and then apply your result to Mr. Y, it will not work, right? You have to be very careful. So correlation helps us to predict linear relationship. Correlation value will range between -1 and +1. Pearson correlation coefficient is very sensitive to outlier. You know outlier? The value which is deviated from the central value, right? The most deviated from the central value. Generally, you must ignore the outliers while calculating the Pearson correlation coefficient. And strong correlation doesn't imply cause and effect. Though correlation is there statistically, in reality, sometimes there may not be relationship. So you have to be very careful. Any question on correlation?
No, sir.
No question.
Sir, in last you said there can be strong correlation, but it cannot be the main cause. Is it true?
Who asked this question?
Samaya.
Yeah, that is a good question. Why do you hesitate to ask?
No, sir.
Very good question that is, right? So strong correlation, but no relation. How can you say? For example, you and me are doing a project, right? We both
yes,
are doing a project. I am asking you to collect data. Collect data about the rainfall in your city. Which city do you live, Mayank?
Sir, Nagpur, Maharashtra.
Okay. So Mayank is in Nagpur. How was the rainfall? Recent rainfall in Nagpur?
So yesterday there was heavy rainfall, but today
Heavy
it's sunny.
Okay, done. So for last 10, 25 days or 30 days, you are measuring the rainfall. Rainfall in centimeter you are measuring, right? And also that is your X variable. And Y variable is number of malaria cases that is getting reported in Nagpur. Number of malaria cases that is getting reported in Nagpur. And now you have the X variable also, Y variable also. Now you plot a scatter diagram. what it will show? It will show as the
Positive.
rainfall increases, malaria cases also will increase. Am I right?
Yes, sir.
Right. So when you calculate the R value, Pearson correlation coefficient, that will also confirm that R value is strong, relationship is strong.
Yes.
Does it mean rainfall causes malaria?
No.
But your statistical study tells that rainfall has a strong relationship with malaria cases, number of malaria cases.
Yes, sir. Yes.
So you see, I'm not, this is certain cases will be like this. That is what I'm trying to say. You should not simply blindly look at the scatter, and if you speak completely statistically, then sometimes it may become meaningless. You have to be careful. Use your common sense. But
Yes,
then
sir.
why malaria cases are increasing as the rainfall increases? As rainfall increases, mosquitoes will reproduce more. When mosquitoes reproduce more, then malaria will spread and malaria cases reported will be more. So this is called a factor confounding. So you should not quickly jump to the conclusion. You have to be careful. That's why I told you mix up some common sense also always when you are working. And right?
Yes,
But
sir.
most of the time, your prediction should be correct. But 20% of the time, you have to be careful.
Okay, sir. Thank you, sir.
Yeah. So now one more.